Hello, everyone, and thanks for attending today's Around the Kitchen Table webcast with Global and Strongbox Data Solutions on taking back control of your data. My name is Nick. I'm one of the directors here at Global, and I'd like to welcome our partners and customers from not only EMEA, but across the US as well. As we're all navigating these unprecedented times, I hope that everyone is staying safe and well. So by way of introduction, I think it's fair to say that many organizations across multiple industries are facing huge challenges, not only handling massive data growth, but files are often scattered over multiple data silos with little or no effective management. It can often be described as a digital heap, and finding that data can often be like looking for the needle in the haystack. But don't fret, over the course of the next few webinars with Global and Strongbox, we're going to take you through some topics that will help address these problems. So today, we're going to be looking at taking back control of your data. The next session coming up on June 9th will all be about protecting and managing your data with Strongbox. And the third part on June the 16th will be a bit of workflow magic, how to get the most out of the data once StrongLink and Strongbox have done their magic on capturing all your data and metadata. So on to today's topic of taking back control of your data, we're going to address a few key questions that are facing pretty much everybody across any data industry that uses large amounts of storage, be that NAS, SAN, S3, or LTFS. So what do you do when your storage fills up? What do I have and where does it belong? And how to manage data storage silos, especially in a multi-vendor environment. So to navigate us through these turbulent waters of data storage, I'd like to introduce Floyd, the CEO of Strongbox. Floyd has been in the data industry, I guess, with SANs, file systems, all sorts of things for 20 plus years. So just like to hand over to Floyd to say a few words about himself and Strongbox.
Thank you, Nick, and thank you everybody for joining us today. As Nick said, I'm with Strongbox Data Solutions, and we're a company that for over 13 years now has been focused on really managing large amounts of data. We began originally with a tape-based system, but realized that our customers had more to do than just with archive. So in today's presentation, what I'm going to do is show you a little bit about how our product StrongLink addresses these problems and what we've learned from our customer over these many years. Let me just share my screen and quickly move in. So I start with this slide about data growth, and I do so knowing that almost every presentation you'll ever see will talk about this exponential growth of data. And I do it almost with tongue in cheek, because even though mostly when people talk about this, they're looking at it in the sense of what are the trends. But I think about this in how does this impact me as a data owner or as a data as a data center manager, because as data grows, inevitably, especially in our modern world, our digital world, that data is going to outlast the storage it's on today. It's inevitable. So the question then becomes, do I have a storage problem? What class of storage should I do? How does it grow? How do I know that my data is on the right storage? And then what happens when that storage needs to be replaced? How do I manage the workflow, and how do I manage continuity in our business? In addition to that, how do I back up this data across multiple silos? How do I make sure that I've got the best utilization out of that data? And then how is it even possible to archive, or even to know what I can archive? The problem is that in most environments, there is not one type of storage. There's usually multiple types of storage, which may also involve multiple protocols, whether one type of workflow requires SMB, another NFS, or a SAN type workflow, or DR. This inevitably leads to silos within an environment. either because there's different file systems, different vendor stores. It could be a merger of two companies that bring in two different platforms, or it's just time. You know, inevitably the storage needs to be replaced. So how do you do that across time? The problem is that mostly these are storage problems because the users themselves are mapped to a device. So it seems logical. I have my data, I put them on a NAS, I put them on a SAN, I put them somewhere. And where do I go to look for that file? I go to look to that storage. Well, what happens then when that storage becomes overloaded, or that storage becomes, it needs to be replaced? Or I realize that this is my most expensive storage asset and I've got data that is sitting on there for a long time. The problem then is, how do I know, if I move that data to an object store, to tape, or to cloud, or to another NAS, or to a SAN, or back and forth, how do you know where that data is? Because inevitably you're disconnecting the user from the device. So the goal here really is, how do you make sure that the users are connected to their data and not to their device? Well, part of the problem is just not knowing enough about the data so you know where it's placed properly. So, for example, I often ask customers, you know, how active is the data on your storage? You know, do you know what's on there? Or how do you know that that data is on the right storage type? Or how do you make sure, if you are moving it to a different storage platform, that you can do so without interrupting users or without adding more burden? And then how do you ensure that the users can find their data, particularly if it has to move over time or for reasons? The traditional industry focus is that, you know, as data growth was typically seen as a storage problem. Why? Well, it's obvious. When the storage fills up, what are you going to do? You call the storage guy to add more storage. There were data reduction strategies, which, whether it be deduplication or other sorts of strategies to try to reduce the data, but inexorably that data grows and it continues to grow. And then the problem is that, if you bring just a storage-centric or a storage-only solution to this, you'll run into the problem of, well, now I'm either locking myself into one vendor or one storage type, or I'm adding complexity to my user community because they now have to move from one store to another, or I have to have manual processes to move back and forth. All of this adds complexity to the users. It adds operational overhead to the IT administrators, and it just makes it much more complex. The real key here is knowing what you've got. And we say it's all about the metadata. And it's really the metadata that becomes the source of truth for everything to do with it. Of course, there's multiple types. There's file system metadata, such as the age of the file, how often it's accessed, path, permissions, etc. There's rich application metadata in the headers of the file, whether it's an image that comes out of an electron microscope, or seismic data, or netcdf metadata in a research environment, or image information in media and entertainment workflow. There's relevant information in there that can trigger, that should be able to give you information about how that data is and what it is. And then there's external metadata. And that could be something, it could be a job sheet, it could be a script, it could be an electronic lab notebook, it could be an Excel spreadsheet. External information that might be housed in a database or a MAM or other solutions that also add information. And then, of course, there's user-created metadata. These, again, might be metadata that are created by the user in external systems, or simply scribbled onto a notebook of their own, to give them more information about what these files are, what they belong to. The problem is that all of these different sources of information are handled by different types of applications and are rarely able to be looked at together. which means that it's like looking at a roadmap where you only see the lines but no labels, or labels but no terrain. Without all of the information being able to work together, you only have a part of the story. So what we say is being able to aggregate this metadata, it provides you with a global view across all of these informations that now you can take action in. Each metadata has different value. And just as the data will get trapped in silos, also the information about the data can get siloed or locked from others. So by being able to aggregate these different sources of metadata, it gives you that complete picture so that you know what you've got and you know how to take action on it. So the benefits here are when you've got a normalization of all of these sources of metadata that can drive policy-based management of your data, then you can bridge the heterogeneous multi-vendor storage silos. You can automate workflows between data migration, data preservation, and other workflows. You can provide multiple protocol access across storage types, and then you can also reduce complexity and costs. So, and I'll show you how we do this in a moment, but at the end of the day, what our goal here is taking all of these aggregated sources of information and making sure that people can use this to focus on using their data, not running around into different store types or different areas to just try to find it or wrangle that data. What StrongLink is, and this is our flagship product, StrongLink is software that uses this aggregated metadata to do precisely that. In other words, to logically decouple the physical device from the user so that users and applications are mapped to their data, not necessarily to where the storage is. So a common problem we'll see in data centers is database administrators, system administrators may want to move data from one place to another, as I said, but how to do that without disconnecting users? By creating this abstraction layer where StrongLink is able to present a global namespace of all files across all storage types from any vendor, it means that now the user is mapped to their data. And if that data moves somewhere else, the user doesn't even know. The user just sees that data. And so that behind the scenes, an administrator can be making copies, can move that data from one place to another, can manage where that data lives without necessarily having to interrupt their users. We do this through, again, this aggregation of metadata into a repository. So this essentially then becomes the brains of the system. By having this correlation between, the age of the file or how often it's accessed, or particulars about the application or user-based metadata, and feeding those into our engines, what we can do is create this global namespace that can bridge all of these different store types. Now, there's many different types of workflows that this needs, and not all of them can sit behind a virtual file system. So, and that's another aspect of this, is that once you've got that data, being able to access it from any protocol on the front side. So what we do is we're enabling customers to have direct I/O, which means that for latency sensitive or high IOPS workflows, the data from existing applications can go direct to the disk, just as it does today. Nothing stands in the data path, nothing gets in the way. Meanwhile, on the side, StrongLink is able to harvest that metadata out of this landing zone and then take action on it to move it to other partitions of that disk array, or to other disks, or to tape, or to cloud, and to manage copies across them all, and perform functions that sometimes people think of as a tiering type function, or an HSM function, or simply an archive function. At the same time, by being able to manage this and control access, we can present a virtual file system with any protocol that enables users, based on their permissions, to be able to look into and see any of those data across any of the storage. So you may have an object store for nearline or bulk storage, or for second copies in a production environment, or even as a primary storage in some environments. And that object store may only present an S3 interface. With StrongLink, a user can come in and see that data through NFS or SMB CIFS or other protocols on the front side. In the same token, as copies are managed from one store to another, the users can see that data without needing to know where it's moved. And I'll demonstrate that in a moment. So at the end of the day, by having the intelligence derived from the metadata to enable the positioning of that data to be dynamic based on policies, based on user or workflow policies, based on retention requirements, based on tiering or other sorts of economic drivers, an IT administrator can look at all of their different storage resources and decide, what is best for them and how they can do that. A couple of points here. StrongLink does not use symlinks, doesn't need stubs, and puts no agents. StrongLink is a data-driven environment. This is not a storage platform. It's a metadata-driven environment, a platform that enables you to connect to your storage without adding proprietary hooks. It wouldn't be very good of me to say, yes, you can overcome vendor lock-in and do a storage neutral, vendor neutral solution if we're requiring you to add vendor hooks into our platform. We don't do that. We're not altering the file systems. We're not adding agents to the storage. In fact, even to come in through our UI, it doesn't require any client software to be installed. And so what that means now is that as a tool set for IT administrators, they can adapt this system to their environment. And so the result is that now when you've got this aggregation in a global namespace, you can have multiple ways to access and control how users are able to see their data, allowing you as an IT administrator to manage that data across multiple stores in the background. And I'll demonstrate this for you in a moment. Simple example here is coming in through the global namespace on the front, enabling us to see, as I see on the right, standard file shares that look to me as a user just like a normal mount to any file system. And I'm going to switch over to actually demonstrate how this looks in real life. So this is an instance of StrongLink. I'm in Northern California, and this is an instance of StrongLink that is running in our lab in Oregon. On the right, you'll see that I'm mounted to, there's a couple of SMB shares, and this is a global namespace view of files that are in the system. As a user, I may not even know that StrongLink is there. I simply see my files. I can open them. I can drag and drop files into and out of this. I can behave like in the way as I would with any normal file system. However, on the left, if you go through our web UI and you look at StrongLink, you'll see that there's a lot more information available to you. So down here on the lower right, you can see the store data, and I'm going to expand this so you can see it easier and look at full detail. So you'll see that down here, that this file actually exists in 3 different locations. There's a primary copy that is sitting on a NetApp filer. There's a secondary copy that is sitting on tape, and there's a third copy that is sitting in Amazon. I've also got extracted metadata, and this happens to be an image, so it's pulling the camera metadata out of that file. And I've got some custom metadata related to a project that I created. Now, sometimes when I talk about custom metadata or schemas, people think, oh, well, then I have to have a database administrator, or, my users don't know anything about schemas or any of that. And we understand that, which is why we created it in such a way that any user can create metadata if they have permissions to do so, and create this on the fly. Multiple types of metadata can be created, multiple fields. A common one that we see is a retention date or a project ID or other things. So users can create this type of metadata on the fly as they like and use it immediately. I don't have to call a database administrator. I don't have to wait for a database to reset. I can immediately create this metadata, add this metadata, and then start using that metadata directly within my system. So this image here, immediately that metadata is available. So why is that important? And normally you wouldn't apply these metadata file by file, but you would do it more as part of a collection. Well, by being able to tag this metadata with any type, or tag these files in a workflow with a department ID or with some other reference to a job or to a project or anything, it means that you can do a lot with the system and make sure that you know where that data is. Building queries. A query, for example, if I want to look at a query that searches for that particular ID, but maybe I also want to do a query that looks for access time from the file system. Here, in a simple query that a user can create, they can manage a query that looks across different metadata types. But more importantly, as an administrator now, I can use queries like that or metadata driven to schedule jobs, tiering jobs or other copy jobs or outgest, where I can base it on a query, for example, or I could base it on a path to say that every evening or every day or every week, take all the files that haven't been accessed that are part of this project and move them into the cloud or onto tape or into some other storage type. And you have the ability then to take this view across the entire platform to be able to see this. I can clearly go into a lot more, and I will do when we get into workflow, but the net takeaway here is that from a central point of view, I can manage different types of files. And let's talk about different types of storage. I can export these as virtual file systems, such as I've done here. This entire global namespace here is this archive namespace is exported over here on the right as VFS1. This one is exported as test2, a different namespace. And I can freely export all or parts of these depending on the workflow and the use case. Importantly as well, when I talked about, the problem of migrating data when one storage platform gets old and another one, we have a thing called a smart pool, which enables you to manage multiple otherwise incompatible storage types in an even distribution policy. Later on, when one of the file systems or one of the stores is ready to go end of life and is replaced by something else, I can do that as simply as changing the smart pool and then going back. As a user over here looking at my data, I would not know that anything has changed, because behind the scenes, the platform can now be migrating that data directly to the new storage. So at the end of the day, what StrongLink is able to do in a scale-out architecture is, without adding anything to your storage, without adding stubs, symlinks, or any agents, being able to integrate and provide you with an automated workflow that can scale to extreme levels to manage your policies for the data, so that your users are able to look at their files And again, look at them across any storage, whether it's out of band, such as in a tier 0 or a very high IOPS, or in band potentially for different types of workflow. Starting small and scaling so that you can provide an environment where your users are able to see their files, work on their files, and you as an administrator can optimize your storage. So a couple of key things, being able to, and we'll talk about some of these in our next presentations, such as multi-site for DR and data preservation. So you may ask, and one of the things that often these types of solutions is how are they priced? And the key here is it's not priced by capacity. We're pricing this by performance, meaning if you can scale the system from a single node up to as many nodes as you need, and these are our server nodes. This is software. These are server nodes that can be on your servers or VM. And from that, you can determine, at what performance level you need. And then based on that, you can move as much data as you want, whether it's a massive archive that you want to create or adding other data. Our point is that over time, it's very difficult to know how much data you'll have. And so your bill should not be contingent upon how much data you have, but really more like a network switch where you buy the performance you need and then run as much data through it as you can. Again, we're not adding proprietary hooks, whether it be agents on your storage or stubs or symlinks. We're compatible with any storage type from any vendor. And from this, we're able to give you the ability to have policy-based automation across all of your different storage platforms. And then we say, reduce storage costs by 80%. Well, how can that be? That seems like a marketing number. Yes, it is an average number. But what we find with our customers is by being able to be intelligent about how much data they keep in their primary storage tiers and limiting that growth by having a seamless ability to offload to lower cost platforms, whether it be cloud or object or other nearline stores or tape, it means that they're not spending money on file systems and growing file systems where the majority of that data is inactive. And typically we see 70, 80, sometimes 85% of the data on primary systems has not been accessed in 60 days. So why does it stay there? Because it's very difficult to move it without disconnecting the users. And then by creating this as an automated platform with central control, it also reduces the operational expense for your administrators. So at the end of the day, what StrongLink attempts to do is remove the complexity so that you can adapt your storage environment to the day-to-day changes of your use. Provide a global view and enable collaboration, even remote collaboration, as you saw me logging into a remote system in another state. Being able to reduce your storage costs by automating the tiering or moving data to archive in ways that don't require human intervention. And then enforce data protection through automation of data lifecycle management policies and other things. And we'll talk more about that in our next session. So with that, I'm going to turn it back over to Nick, and we will open it up for questions. And I should have mentioned this. Please enter your questions in the chat if you have them, and we'll do our best to answer them.
Cool. Well, that was really interesting, Floyd. Thanks very much. And as Floyd said, you've got a chat box at the bottom of your screen. So if you've got any questions, then do feel free to send them in. I just wanted to pick up on a couple of points myself, Floyd. One, especially in this kind of era, we're here with the pandemic, is questions on how can StrongLink help sort of with remote working. Obviously, you can add in access worldwide effectively to, I mean, you were saying you're in Northern California, you're accessing a system in Oregon. That interface can just run over a web UI. Presumably there's different access permissions and such that you can set to allow certain users to see certain information.
Mm-hmm. Sure. So again, the idea of StrongLink is to be able to integrate directly within your environment. So it's a roles-based system. So what you see and the data you see and the functions that you're able to access is based on your role, which is tied back to Active Directory or LDAP or other authentication. So you're not having to manage a separate authentication system. So as you make changes in your AD groups or other permissions, those flow automatically into StrongLink. Also, we're maintaining all ACLs or file permissions. Those are metadata to us, and so we're able to inherit those, and so that what you are able to see and do in your role is also consistent within StrongLink, whether it's directly on the storage or through StrongLink, it's the same.
And those data sites, so that global view could just be any NAS, S3 bucket, tape library, whatever you have. Yeah.
And it's a tricky thing to do, because if you think about it, maybe I've got an object store that only presents S3, or I've got a NAS that only presents SMB. Well, by being able to come in through multiple protocols, what you're doing is opening it up so a user could come in through other protocols than the storage itself supports. And so we're translating those permissions and translating those access, those abilities across multiple protocols. So some groups of users may be able to come in through one protocol, some through another. So you can really spread out and make it very easy for all of your different users and user types to access the same data, even across different storage types.
Perfect. And in terms of the metadata queries and search, I assume that you can kind of aggregate those searches to really drill down. If you imagine maybe in media and entertainment, you might be running a project for a specific broadcaster or production company or something, and be able to kind of drill down and find all the data that's allocated or part of that project, and kind of allow users to see that.
Yeah, absolutely. And I'll quickly go back to the demo and show you. So this query here, which is just a project ID with a retention date that I did earlier. So running that query is going to produce a subset of files. And this could be a lot or a few. And now this subset of files are data that are scattered in different types across different stores. With this, I can apply metadata globally. But also I could run a report. So I could run a query-based report that would give me back, what the utilization of that, if I'm doing internal billing, or if I want to understand where this data goes. I can use that same query that is layering up, again, the different types of metadata to do a job, and that job might be, a file verification job. Data that has been sitting there, or outgest or export that data to somewhere else, and even display it as a virtual file system, or copy that data and so forth. So it's really the aggregation of these metadata in being able to very easily apply these different rules and know what you've got, whether it be modified time or other types of metadata that might be available, is really one of the powerful aspects of StrongLink. And being able to do this in a way that doesn't require a lot of specialized training to be able to manage.
Perfect. We have actually had a couple of questions in. One is, just look at this, just asking about your licensing, your cost model. Obviously, you said it's not based on like a terabyte sort of capacity. So how is it licensed? Sure.
So and I'll quickly switch back to the picture. So StrongLink is installed on a server. Typically, it's a bare metal server, like a Dell R630 class 1U server. And the only real requirement here is that it's got an Intel processor and a certain amount of SSD for the metadata cache. So the pricing is based actually on the number of CPU cores allocated. So in a typical HA environment where we would have 3 nodes, you maybe have 16 or 20 cores per node, depending on your performance. You license whatever, if it's 60 cores, for example, and you're done. It's a subscription that includes all upgrades, all maintenance. Obviously, there's discounts for multi-year purchases. But once you've done that, there is, move as much data as you want through it with no limitations. The only variant in that is because not everybody needs tape, we license the tape capability separately. But here again, it's not by capacity. You license by the number of drives. So a simple archive where you've dedicated 4 drives, for example, or 6 drives, if it's a higher throughput workflow, again, on any tape library from any vendor, you could pump as much data through that as you want, and petabytes without additional charges. And as well, with tape, our legacy is in tape, so we're again support all libraries, even platforms like Black Pearl from SpectraLogic and so forth. It's really meant to be compatible with them all. So pick your performance level, license the number of cores you want, and have at it. There's no additional charges.
Great. So that's pretty compelling for starting off with kind of like a 1-node LTFS archive, and I know we're going to touch more on that, I think, in the next session. So we won't go too much further into that. Just one other question actually that's come in is on capacity that you can manage and kind of number of files. Is there kind of, how do you presumably millions, billions of files or especially across object store and cloud and files, different file systems?
Well, I mean, that's one of the good news about the way the system is architected, is there are no limits, which sounds, I'm always skeptical when somebody says there are no limits, but it is literally a scale-out architecture. So from a minimum for HA, every time you add a node, you're adding more throughput capacity. The number of objects, I mean, even on a 3-node system, we're in the billions of objects. And you can add as many nodes as you want. There's no limit in the system in terms of the volume of data at all. Even a small system can handle, tons of volume. And so we've got customers in the 100 petabyte range that are looking to grow, significantly, every year, even towards the end of the next 5 years into the exabyte range. So volume of data, there's no limit. Throughput, no limit, because you just can keep adding nodes as you need. And object count, there's no limit, except for you may need more nodes so you have enough metadata space for all of those files. Okay.
Perfect. And just one other thing that I was kind of wanted to ask, actually, picking up on your presentations, this is a question for myself. You're talking about not having to, a lot of systems out there stub files or have syslinks, those kind of things. Obviously you guys don't. What's the advantage of that in your system, do you think?
Sure. Probably the biggest advantage is you're not trapped or locked into us. I mean, there's logistical advantages. So if I go back to my picture here, this any to any, in a typical tiering sort of a workflow, when data comes into a high performance tier, it may leave a stub or a symlink, but the file essence is moved maybe down to tape or to an object store or something else. Well, that creates a hierarchy, a path. And when you may hear people talk about rehydration, it means that when a user wants that file, it has to then go back up through that same path. Well, that's very inefficient. You may have, for example, a lot of data landing on tier 0, and you want to empty that out as quickly as possible to tape. Well, it makes no sense to go down to one tier and then to tape and then to get it back up and so forth. With StrongLink, because we manage it all in metadata, you can go any to any. So I can go directly from my tier 0 to tape without having to land in a disk cache or anything. And then I can go directly back from tape, direct to the user, direct to another store or to another location without having to go back through that same hierarchy. So not requiring you to lock into us as a vendor, because we're not putting links or agents or proprietary things in there, and not requiring you to lock into a particular file path. So basically what it means is you've got a much more resilient system that you can adapt to the changes that will inevitably occur in your use cases, even in your storage infrastructure over time.
Okay. Yeah, I think we've just actually got one other question just popped in. I know we're up to the wire on it. I think it's one of your existing customers. They've got a Strongbox system at the moment, and they're looking to upgrade to StrongLink. I understand there's an upgrade path coming together, but I don't know.
Yeah, we can. We do have a very smooth upgrade path for Strongbox customers, and we've got multiple levels. We make it very advantageous for you to do so. The best thing to do would be to contact us either at info@strongboxdata.com or contact me directly, or depending on your geography, contact your local sales representative, and we'll put together a package for you and show you how that is. It's a very simple process, where it's a database migration from Strongbox. All of your data is maintained. Anything that you've got sitting on tape already, you don't have to re-ingest that. It's all done in metadata, and then from then on, you can take advantage of the other StrongLink features.
Brilliant. Okay, I think we'll call it a day for questions, because we're conscious that don't want to take up everybody's time. So what I'd like just to quickly do is pop back to remind you guys, sorry, of the upcoming webinars that we have. So Floyd will be joining us again on the 9th to talk about protecting and managing your data. We've talked a little bit about that. We're going to cover kind of DR, LTFS, and some of the things that we've sort of talked around about today as part of this presentation. And then on the 16th, workflow magic. So that's really, as Floyd was saying, that the key, the secret sauce is the extracting the metadata and the system being metadata aware, and then how you can use that metadata to build your workflows and drive efficiencies through the system. So those 2 dates, please, for your diary coming up. So as I said, I've been Nick Warburton, Director at Global Distribution. You can reach out to me directly at nickw@globaldistribution.com, or you can go to globaldistribution.com for all of our contact details, both for EMEA and the US. And I'd like to say, obviously, a big thanks to Floyd Christofferson. His email address, very simple, fc@strongboxdata.com. Sorry, let me get that right. And of course, any information you need from Strongbox, you can get from strongboxdata.com. Very straightforward. So thank you so much for joining us. Thank you very much to Floyd for taking us through it. And I very much hope that you can join us next time around the kitchen table for more information on Strongbox, StrongLink, and managing your data. So thanks very much. And I'll just pop back and we'll say goodbye. So goodbye from me.
Yeah, thank you very much, everybody. And thank you, Nick. And see you next time. Thank you.
See you next time. Thanks all.